Hi my friends, today we try to model this sheet metal part, a flange. It is not so complicated, but we see here a deep drawing which cannot be flatted. You cannot obtain a flat pattern from this, from the mid and round part. We'll see everything here, but let's take a look at the drawing. You see there are some dimensions here. The external diameter is 300 millimeters, internal 108, and from this 176 we have that deep drawing. There are three identical protrusions here with a flange, a small flange, this one. So we can start, no problem. Sheet metal millimeters template, the first sketch with that circle of 300 millimeters, another one with 254, and another one with 176. Home. Then we draw some lines. Okay, escape, trim, we place this line to contain the center point. We add here a small element. You see, I go up with the cursor being with the mouse button pressed to draw this arc. Then trim also here. The radius, these are tangent, and dimensions are in the drawing here. Yes, this is the line on the center of the circle, and this is that small cut. Radius, same as radius, 2.5. 2.5, 2.15. The distance, now I trim the end of this line. I place here a dimension of 2.5 and because this is tangent, this dimension is not necessary, but I place it here. Good. Now some fillets. As you can see, radius 5, radius 2, 12, 15, 25, 28, 28, 25, and fillets 2. 2 is by default and is here. Then 5 between the arc and the vertical. 12 between these two entities, and 15 between these other two. One dimension needed, and that dimension is the distance from here to the center. Dimension of 100 if you take a look to the drawing. Now it is fully constrained. Once again we see here 100, and now all these lines and arcs I multiply in a circular pattern for 3 times. So circular pattern, select all of these without this circle, about this center in 3, not 6 instances. 3. Okay. I apply split to cut this arc, and I make construction lines, this one and this one, entities, arcs, construction. Okay, finish sketch. Face. But before face, we have to establish the thickness of the sheet metal. It is 1. So I apply sheet metal defaults and I erase the thickness in the styles editor with 1. Okay. Now the variable thickness is, as you can see here, 1 millimeter, and you have all the other dimensions here, of course. Good. Face. This is what we want to consider as a part. The thickness is 1 millimeter. Okay, and we have the part, as you can see. I apply material to have a nice presentation. Steel carbon, so you see the part. F6. I apply a flange by using this edge with the width of 20, not 25, which is by default, and this solution because I want this face to be aligned with the small face here, and which goes to the center of the part. Okay. Other element here is this radius 5 to the both ends. This means that I have to use corner round, not fillet. 5, and I select successively this end and this corner, the two corners. Okay, good. Now I multiply this small flange for 3 times about the center of the part. Circular pattern, flange and corner round. These are the two features to be placed on the pattern, and I select the center of the part, or I select the center point, or I select the Z axis. Yes, I have many possibilities. 3 items, not 6. Okay, good. As you can see, I use the environment sheet metal. Yes, all these tools are associated with the sheet metal. I try to use sheet metal to create that deep drawing in the middle. Let's see what happens. I select this plane, F7 to see inside. I project this generator of a flat cylinder, project this generator, and I draw 2 lines. 1, 2. Now I can apply on these 2 lines which have the dimensions. Let's apply dimensions firstly. You see 176 is the cut which we already used, where the small generator was projected. Then we consider 18.5 and the diameter of 157 together with the diameter of 108. Good. This means that I have to project as a center line the z-axis, and we have this axis here. Nothing else to be projected. I disable this aspect, and I apply 18.5 between this face, this end of the generator, 18.5, the diameter of 108 of this end, 108, and the diameter of 157, 157. Okay, I finish this sketch, but firstly I want to make this construction line. Finish, and we can use the contour roll, we have an axis, we have a line, we can select which direction is the thickness, this or this. Yes, it could be outside or inside. We select outside because we want to have, no, inside, to have this kind of connection. Okay. Oh, but only 90 degrees? No, 270, 3/4 of a circle, 360. Now this is red. If you place here 364.9, 64. No, excuse me, 359.9, you have a successful contour roll. Okay, but what about this? This is a gap. We don't want to have any gap here. Oh, this is not useful at all. What about the flat pattern? I apply this and errors. I cannot make flat this object. F6 again. So I renounce to make that contour roll. So I delete it, but I don't want to eliminate the consumed sketches. Okay, I need them. To make that emboss here, I go from the sheet metal environment to 3D model environment, my friends. I edit the sketch because now I have to create a profile. You know this. F7 to see inside, and I apply offset of this combination of two lines in that direction, but with the value of the thickness. You see, until I don't write all the letters, the symbol is red. If I add the last letter, S, this is not red. Yes, this is the solution. I create an offset with the distance of the thickness of the part. The thickness, you know, it is the symbol which is associated with the model. The thickness is 1 millimeter, and you see this here. I draw a line between these two ends, and here I make another combination because there is no such a line here. I draw a line from this point down. I extend this line to the new line. I trim that extended that line, and I change this one from construction to normal line. Finish sketch. Now I use revolve. Yes, not here, but in the 3D model environment. Revolve, and we have the full 360 degrees cover of the new feature. Okay. Is this okay? Yes, it is. Why not? What about the flat pattern? I go back here and I apply create flat pattern. As you can see, this means that the emboss or deep drawing is not considered, is not flatted, but the flanges are. Okay, go to folded part, go back, and we have to apply some fillets, as you can see here. R 3.5, R 5.5 outside. What about the inside? The inside we will subtract or add the thickness to have the complementary element, which is filleted. This is also a fillet, and this is also a fillet. So I select this, I apply fillet of 3.5 plus the other one, which is 5.5, plus this one, which is 5.5, no, this is 3.5 plus the thickness. The thickness must be the same all over the part. Yes, I don't use sheet metal which creates that corresponding fillet, so I have to simulate the same construction, plus this one, which is 5.5. You'll understand if you think a little about this, minus thickness. Okay, good. Now all we have to add are these holes. They are 6 holes of 10 millimeters, equidistant, at a distance of on a circle with a diameter of 130.4 millimeters. Let's do this. We select this face, we create a sketch, we draw a line. In my opinion, this is the simplest way to create a hole on from the center of a circle. This line is vertical, its length is 130.4 divided by 2 because it's a radius, of course. Okay, finish sketch, hole, and 10 millimeters is already established here, and through all is the solution. Okay, next is a circular pattern of this feature about this center with, yes, you are right, Inventor, 6 holes. Okay, we see that we finished the part. Nothing else is to be placed here. Let's see if the volume is this one. Part 3, eye properties, physical update, and the value is here. Copy, close, go to drawing and apply text beside this text with the value, paste. You see it is the same. Control Z, home, and this is the part, my friends. So all I want to say is thanks for watching. Bye bye.